Hey, this is Mr. A, and this is section 5.4 using sum and difference formulas. So if you know how to add and you know how to subtract, you know how to use these formulas. No, you don't. I'm going to explain it to you right now. So let's say we have an angle that can be added up. So you can see sine of u plus v. So this angle can be added up between u and v. And you can see there's a formula to this. We have sine of u times cosine of v plus cosine of u times sine of v. And we have not only the sum, but we have the difference. We have sum and difference of cosine. We have the tangent as well. So the biggest difference is I want to show you how to use these formulas. So of course you'll always have these formulas with you, and they're on your equation sheet, and you don't have to memorize them. And so we have finding the exact value of cosine of 75 degrees. Now take a look on your unit circle. 75 degrees is not on my unit circle, so we can't do that. So we have to do cosine of two things that are on my unit circle that might add or subtract to 75 degrees. So I'm going to use 45 degrees and 30 degrees because those add up to 75 degrees, which means I'm going to use the sum formula for cosine. So you can see cosine of u plus v, which means I'm going to call this u, I'm going to call this v right here. And all I'm going to do is I'm going to plug it into my formula. I have cosine of u, what's u? 45 degrees. I have cosine of v, which is cosine of 30 degrees. You can see there's a minus sign in between, so we put minus right there. Sine of u, what's u, is 45 degrees. And sine of v, which is 30 degrees. Now I can go to my unit circle because I have these values on my unit circle. Cosine of 45 degrees is root 2 over 2. If you look at your unit circle. Cosine of 30 degrees is root 3 over 2. Minus sine of 45 degrees. What's sine of 45 degrees? That's root 2 over 2. And what's sine of 30 degrees is 1/2, which means I have root 3 times root 2. That's root 6 over 4. Minus root 2 times 1. That's root 2 over 4, which means this is root 6 minus root 2 all over 4. And that is what the exact value of cosine of 75 degrees is, which is not on my unit circle. But we can use the sum and difference formulas in order to find out the exact value of those things. So let me give you another value of sine of pi over 12. Sine of pi over 12. Now, I would suggest it's a whole lot easier taking these radians and changing it in degrees. But I'm going to show it to you in radians. I'm going to show you the hard way. The easiest way is just change it into degrees. So pi over 12 is the same as pi over 3 minus pi over 4. If you get common denominators, you'll see that'll equal 1 pi over 12. So what do we really have? We have sine of pi over 3 minus pi over 4, which means I'm going to be using this difference formula, which means this is my u and that's my v. And I'm just going to stay consistent. I'm always going to use pi over 3 as u, pi over 4 as v. So we have sine of pi over 3 times cosine of v, cosine of pi over 4, minus cosine of u, that's cosine of pi over 3, times sine of v, sine of pi over 4. Now I go to my unit circle. What's sine of pi over 3? That's root 3 over 2. What's cosine of pi over 4? That's root 2 over 2. What's cosine of pi over 3? Cosine of pi over 3 is 1/2. What's sine of pi over 4? That's root 2 over 2. And so I end up getting root 6 minus root 2 all over the common denominator of 4, and that is the exact value of pi over 12. Okay? Let's go to example 3. Example 3, we're not really using our unit circle here, but what are we doing is we are taking a look at the exact value of sine of u plus sine of v. Okay? And so we know right here sine of u is, if you can see, said sine of u is equal to 4 over 5. Which means what is cosine of u equal to? Well, cosine of u, keep in mind we have a 3, 4, 5 triangle. So cosine would be 3 over 5. But keep in mind, this is in the first quadrant. It says from 0 to pi over 2. So that means everything's going to be positive right there. Okay, so I use this first sine of u to get what sine of u and what cosine of u is. Then I'm going to take this next one, this cosine of v. I know cosine of v is equal to negative 12 over 13. And think about this negative 12 over 13. This is another perfect triangle for negative 12 over 13. We have really a 5, 12, 13 triangle. That's one of those special triangles. Oh, you're so special. And so you can see here, this is from pi over 2 to pi. So this is in this quadrant right here, quadrant 2, which means what do we know in quadrant 2? The cosine is going to be negative, but the sine is going to be positive. So it's going to be 5 over 13 for my sine. Okay, so you're going to use these little stipulations to figure out whether they're positive or negative. Okay, now we can go to my sine of u plus v. Go to my formula, which means this is sine of u times cosine of v plus cosine of u times sine of v. And you can see, what did I do? Before I did anything, I developed what sine of u, cosine of u is, what sine of v, sorry, that is a v right there, isn't it? Sine of v, cosine of v is equal to. Now I can plug in my numbers. Sine of u is 4/5. Cosine of v is negative 12/13. Plus cosine of u is 3/5. Sine of v is 5/13. Okay, and so now I can kind of finish this out. I have negative 48 over 65 plus 15 over 65, which ends up becoming negative 33 over 65, and that is the exact value given these two triangles for u and a triangle for v. Okay, so when you're finding these exact values with these special triangles, make sure you develop what sine of u is, what cosine of u is, what sine of v is, what cosine of v is before you ever begin, and it makes it a whole heck of a lot easier. Next, we're going to prove what we call a cofunction identity. Cofunction identity. We did these on the first, actually maybe the second video of what the cofunction identities are, but we can prove it using this sum and difference formula. What do we know? This is going to be my u minus my v, which means I'm going to be using this function right here. So which means cosine of u, that's pi over 2, times cosine of v, which means cosine of pi, plus sine of u, what's u? It's pi over 2, times sine of v, what's v? It's x. Sorry, and that is not pi, that's x, because your v is equal to x. Now, let's just think. What is cosine of pi over 2? Well, cosine of pi over 2 is 0, isn't it? Times cosine of x. Cosine of pi over 2, if you look on your unit circle, it's equal to 0. What is sine of pi over 2? Well, that's equal to 1 times sine of x, which means we're left with sine of x. And we prove that cosine of pi over 2, cosine of pi over 2 minus x is the same thing as sine of x. So we proved this identity on your equation sheet. Okay? And that is section 5.4. Using sum and difference formulas, all you're basically doing is telling who u is, who v is, and then plug it into a formula. Wham bam, thank you ma'am, you're all done. Okay? See you guys. Bye.